Hi, this is Matt Sherman, and today we're going to work through our tech talk for sales training. This video is really intended to be a train the trainers sort of thing. This instruction, this training session is best done live with a developer, and it's meant to be sort of interactive. But to just sort of frame the talk and to, provide some guidance for future instructors, I'll work through it here in this video. The goal of this talk, the audience is salespeople. The goal of this talk is to have a good understanding of tech stacks and programming languages, and we'll talk a little bit about open source software. The reason we're talking about this is our talent clients, technical recruiters, engineering managers, that sort of thing. They think very, very technologically, and they are seeking certain technological skills. And we at Stack Overflow want to be a really good partner for them. We want to help them through this thicket of jargon and this very complicated industry. So that's why we're doing this training today. So first, a quick definition. What is a developer? Well, there are lots of technical and technological roles in the world. A developer is a specific kind within that. Developers are people who write code. They program computers. There are lots of other technical roles that are important, but Stack Overflow's stock and trade, our main audience is developers. So when we say developer, we mean somebody who writes code to solve problems, usually doing it professionally. Okay, so what is a stack? Well, a stack is the set of technologies that a company uses to accomplish their goals, accomplish their technological goals. Any piece of software you use is built on a stack. There's no technology that just exists on an island. A stack of technologies means there's sort of foundational technologies and layers that sort of build up on top of that. So when you hear somebody use this term, it's a metaphor. But a company is telling you when they say something like, I use a lamp stack or we're a Microsoft shop, what they're doing is describing the set of technologies that their products are built on. Now what's interesting, this is a little tangent, what's interesting is that stacks are getting a lot more diverse these days, and it's good news. A lot of different sorts of technologies interoperate with each other, largely because of the internet and because of open standards and open source. 20 years ago, you'd probably buy all your technology from Sun or IBM or Microsoft. But these days, companies are able to pick and choose different technologies, sort of the best technology for the job, and they all talk to each other, which is great for us as technology people, but it does make the landscape a little more complicated, and so that's why we're going to talk through a bit more of this. Okay, let's get to it. The stack. So I said, okay, the stack is a metaphor. So we talk about the low level of the stack and the high level of the stack, and I'll sort of run through these really quickly. At the very baseline is hardware. It's the stuff that is physical. It's metal, it's glass, it's servers, it's phones. Sitting on top of that is an operating system, and on top of that is a database. I'm going quickly, I realize. We'll talk through each of these. You have a programming language. On top of that, you might have a framework. On top of that, you have the front end. And then on top of that, you have the end user. This is the customer, the person who's using the software. Again, don't worry about how quickly I went through those. We're gonna take this apart bit by bit. We use terms like front end and back end. So I put some sort of braces around what we mean when we talk about things like sysadmin. So a sysadmin typically works at low levels of the stack. And just to be clear, when I say low level, I mean sort of close to the ground. None of these levels is any more or less difficult than the other level. They're all sort of equivalent difficulty. The question when I say something like low level, I mean like how foundational is it? How many things get built on top of it? So sysadmins tend to work on low level stuff. They work on the hardware, they work on the operating system, they work on the networks. What we talk about with back-end people, they probably span anything from a database up to a framework. And then up towards the top, you're talking about front-end developers, designers, that sort of thing, and ultimately the customer. Full stack, you hear this word full stack. Really what full stack means, usually means full stack web. It means both front end and back end. So taking a step back here, we see front end, we see back end. Full stack means that the developers can work on both front end and back end. Really when we use this term though, it's not even a technical term. Mostly it means that you can give this developer a problem and they can handle the whole thing. They are generalists, generally speaking. here at Stack Overflow, the engineers that we hire for ourselves are mostly generalists. We are mostly full stack developers here. It's because we're a small company. We only have 30-something developers here at Stack Overflow, but a big company will have hundreds or thousands of developers. When companies get big, they start to specialize. So each part of this stack here, each part of the stack here is a specialty of its own. So in a small company, you'll have people spanning up and down the stack, being sort of full stack. In a large company, you'll hire specialists. So you'll have a front-end person, you'll have a database person, that sort of thing. Okay, so again, try to keep that stack in your mind, that blue stack. And we're going to walk through each one here. So hardware, it's literally hardware. It might be a server, it might be a laptop or a desktop computer, it might be a phone. Hardware refers to the chip and all the memory and all the physical stuff that makes up a computer. Keeping in mind that phones these days are computers. They're made up of metal, plastic, glass, silicon, some other stuff. But it's just hardware, it's just stuff. So in order to turn it into something useful, we need an operating system. An operating system, a lot of people say OS, is the basic software that you put on a piece of hardware that turns it into a useful computer. All of these types of computers that I talked about, servers, desktops, phones, they all have operating systems. They all have an OS. Some of them even say OS, like iOS. That means it means the I operating system. It's from Apple. But your Mac, that's an operating system. Windows is an operating system. Linux is very popular on servers. And on your phone or on your tablet, it's iOS and Android. Okay, on top of that, you have a database. Now, a database is a deep topic. There's a lot here. We're going to go through it quickly. But the database is the thing that stores the data. It keeps the data safe. It keeps the data organized. It serves up the data when somebody asks for it. If you lose your database, you've basically lost your business. It is really sort of the fundamental stuff. So underneath Gmail is a big database. Underneath Salesforce is a big database. Pretty much any piece of software you use, that data has to go somewhere. And that somewhere is a database. A database is kind of a broad term. It really is sort of self-defining. It means the thing that holds the data. But it's so important sometimes there's a dedicated person, and I'm sure your clients are asking for this sort of person sometimes, called a database administrator, a DBA. We'll talk about that a little further down the presentation here. But it's a really important part of the business. And I'm going to talk to you about two broad categories of database. There's a lot of detail here. And this is why you should do this presentation live in person, because there's going to be a lot of questions here. Okay, two broad categories of database. One broad category is what we call a SQL database, SQL. That stands for Structured Query Language, but nobody ever says that. People just say SQL. There's lots of SQL databases in the world. SQL is the language that we use to talk to the database, to tell the database what we want. Across the top here in that first row, you'll see a bunch of names that you might recognize: MySQL, Postgres, Oracle. These are SQL databases. Another word you might hear for this is relational, possibly, or RDBMS. The thing to understand about this class of database, this category of database, is that it's made of rows and columns. It's like a big industrial strength spreadsheet. So if you've seen a spreadsheet, and I know you have, you've seen what a database looks like. Just imagine that it's running on a huge piece of hardware and it's being shared by thousands of people. That's what a SQL database is. This is a mature technology. It's been around for a long time. It's very structured data. That's important. It's a mature technology. It is a conservative choice. It's not a radical choice to use a SQL database. It's sort of the default choice when you're starting up, a new business or something. It's also very popular. Just about every company, we here at Stack Overflow, really everybody, has a lot of SQL databases sort of storing their data. So this is the mainstream choice. Another thing that's interesting about this is from a skills perspective, because again, what we're really doing here is talking about skills, not so much technologies, but skills. These skills are very transferable. So a person that does MySQL can probably do Microsoft SQL just fine, and they can probably do Oracle just fine. They're not exactly equivalent, but they're about 90% equivalent. So if somebody's telling you they need a SQL person, experience with any of these platforms is probably pretty good. It's probably pretty appropriate. Okay, cool. So SQL in a nutshell. What's the other kind of database? Well, it's a bit it's a bit of a misnomer here. See, the other kind of database we call NoSQL databases. That's a terrible name, but it's the best we got right now. We also call these things document databases, or sometimes we call it a key value store. These are all the databases that don't work like SQL. And the way you can think about them is they work like a folder on your laptop. Now, the folder on your laptop, you can throw anything you want in there. You can throw folders in folders, any sort of file, any sort of whatever you want. You can put it in that folder, and it doesn't stop you. And sometimes that's good, sometimes that's bad, but that's the nature of this sort of database. So across the top there, you'll see some names of databases: Mongo, Redis, Elastic. You've probably heard at least some of these from your clients. I mean, the truth is, these databases are actually pretty different than one another. They're not really the same. They're all sort of specialized in a certain purpose. So you'll see I mentioned here that they are flexible. They tend to be a bit newer, a little trendier, but they're also specialized. They also exist for a particular purpose. In the case of MongoDB, for example, that works like a folder on your laptop. You can throw anything in there and pull it right back out. It can get messy if you don't, if you're not careful, but it will let you put anything in there. Redis is usually for caching. It's usually for making websites faster. Elastic is usually for full text search. So if you want to have like a Google style search on your website, you might use something like Elastic. And there's a few more on there. But the thing to remember here is they're not SQL, and they are specialized. They are made for particular purposes. Okay, cool. So let's talk about programming languages. Again, see if you can visualize that blue stack again. The next level up from the database is the programming language. Programming languages are what we developers use to talk, basically to make our application. It talks to the database, it takes data out of the database and it sends it to you. There are lots of languages in the world, and so this sort of layer of the stack is where most programmers spend most of their time. Look at all those languages. That's a lot of languages, and that is just a small sample. There are dozens, there are hundreds of languages in the world. It's funny. So, people say, why are there so many languages? Well, I mean, the short answer is there's so many languages because we can, because we can have that many languages. All of these languages, at the end of the day, just about, do the same thing ultimately. Ultimately, they all sort of have the same capabilities. But they are very different in terms of their styles, and they are very different in terms of the tasks that they are good for. So if you're wondering why there are so many languages and why so many programmers choose different languages, it's because there are different tasks. There's different styles of thinking, that sort of thing. So programmers, there's a lot of different kind of programmers, and so there's a lot of languages. The other thing to recognize is that for any project, or for any company for that matter, they use lots of languages. To create a basic website, you probably need about 5 languages. On the front end, you'll use HTML, JavaScript, CSS. Then you'll have some sort of back-end language like Ruby maybe. And then behind that, you'll have a database which uses SQL. So right off the bat, that's 5 languages. And that's a very basic website. So a company gets big or a website gets big, you're going to get into dozens of languages in all likelihood. And that's just the nature of it. There is a spectrum of languages, and I already hinted at this with databases. There's a spectrum of languages. On the one hand, sort of a strict style, structured languages. On the other end of the spectrum, there are languages that are more flexible, they're more forgiving. One of them is not better than the other, but there is this sort of dimension, there is this sort of spectrum of languages. The technical terms we use for this are static and dynamic, typically. And the important thing to understand is these are styles. Neither of them is right or wrong. It's just a style. And as we go into it, I'll talk a little bit about why people choose certain styles at certain times. Okay, let's jump right in. Ruby. Ruby is a language. It's very popular. When you're talking about Ruby, in all likelihood, you're talking about Ruby on Rails. But they are not the same thing. Ruby is a language, and Rails is a framework. Now, we're going to talk about frameworks in a few minutes here. Don't get too hung up on it. But basically, they're basically synonymous from a skills perspective. So if somebody's asking for a Ruby developer, what they're asking for in all likelihood is a Ruby on Rails developer. Ruby is very popular. A lot of people get started with Ruby. It's a very powerful sort of environment to build websites. It's really productive. Beginners like it. It's got a great community behind it. So if you need information or if you need help, Ruby's great for that. And it's on the flexible side of languages. So it's a very dynamic sort of language. It's a pretty forgiving sort of language, which, again, for beginners, that's a great thing. C Sharp. C Sharp is a language by Microsoft. It's part of their .NET platform. .NET is not a language. It's mostly a branding term. So don't worry too much when somebody says they're looking for a .NET developer. What they mean 9 times out of 10 is they're looking for a C Sharp developer. C Sharp is often used by big companies. It's sort of a corporate style language. That's who Microsoft's customers are. C Sharp is the language usually, and it often comes with a framework like ASP.NET. So you'll use ASP.NET to build websites, and you'll use C Sharp with ASP.NET to do that. C Sharp is on the strict side of languages. It tends to be very demanding in terms of being structured. Again, that's not a bad thing. It's a choice. If you're just starting out, you don't want too much structure. You just want to try some stuff, and that's great. But as you start to get big, like a corporation, you have dozens or hundreds of developers, you might appreciate having a lot of structure there. So, so imagine like a dozen people trying to write a book together, on a Google Doc or something like that. Would that be a very good book? Maybe not. I don't know. If everybody sort of followed a structure, then maybe it might be okay. Who knows? And that's sort of the philosophy of strict languages is, they're not strict for their own sake. They're strict because you have a lot of programmers working together and you need to have some sort of standards in place to make things sort of work together. Anyway, that was a tangent. C Sharp is one of those languages, fairly strict. Stylistically, it's very similar to Java, and we're going to touch on that now. So Java and C Sharp are competitors. So they're similar because they are competitors. Similarly, Java is, for big companies. It's the term we use for this sometimes is enterprisey, sort of industrial strength, high performance. Java is a language, and there's some frameworks that go with it. Play and Spring are a couple. There's lots of them. At the same time, interestingly, Java is the language for Android development. And also, there's an ecosystem around Java. I wouldn't worry too much about this, but there's a language called Scala that you may come across, and it comes from the Java lineage. And so they have a relationship to each other. I'll take a quick tangent here. So Sun Microsystems came out with Java probably in 1995 or so, something like that. And it got popular. It sort of made certain things easier than what came before it. It was really good for big companies. It started getting really popular. And Microsoft saw that happening, and they said, we got to respond to this competition because, Java was getting real popular, and Microsoft at that time didn't have anything that sort of directly competed with it. Microsoft had programming languages, but not something in the style of Java. So around the year 2000, they created C Sharp and the sort of .NET ecosystem to respond to Java. So what that means from a skills perspective is that you might often find developers that move between C Sharp and Java. They are not the same language, they're different languages, but boy, they're close. If you were to hold them up next to each other, they would look real similar. And I know some people like this that, yeah, they are Java developers, but sometimes they do C Sharp or vice versa. That's a nice thing to sort of keep in the back of your mind if you're talking to a client, trying to find a Java developer. Maybe they should talk to some C Sharp people or vice versa. JavaScript. JavaScript has nothing to do with Java, which is kind of hilarious. It's completely unrelated, basically. They're both programming languages. They look a little bit similar, but not really. Java is basically, or JavaScript has the name JavaScript, basically because Netscape really wanted to have sort of a trendy name, in the 90s for their new programming language. So JavaScript was created by Netscape, which was the first sort of browser company, the first sort of web browser, or first sort of, mainstream commercial web browser. And they had a programming language, and they created JavaScript. So anyway, the thing to understand, technologically unrelated to Java, it's just a name. But there's lots of other things to know about JavaScript. Firstly, it's the most popular programming language in the world, sort of by far. And the reason is all the web browsers in the world run JavaScript. So your phone and everything else, Safari or Chrome or Internet Explorer, they all run JavaScript. So it's everywhere. And every programmer in the world, whether they like it or not, they're going to write JavaScript. They got to write JavaScript. They can't avoid it, despite their best intentions. JavaScript, yeah, it's real popular. Another thing that makes it complicated, this is unusual, this is untrue of the other languages we're looking at here, is that it runs both on the front end and in the back end. So front end means the browser, like I said, Safari or Chrome. Also on the back end is sort of a back end programming language. If that's happening, if somebody's using it on the back end, it's usually Node.js, which runs on the server. There are a billion frameworks for JavaScript. There's so many of them. You'll get to know them over time. I don't expect you to memorize it right now. But you probably recognize some of these names: jQuery, React, Angular. JavaScript is on the flexible side of languages as well. So it's pretty flexible. It's not too hard to get started. It's a weird, funny little language. Speaking as a programmer, it's a weird language. But it is so popular that all of us have to write it. We'll touch on a few more here. Python. It's a very popular language. It's real simple. It's real nice to look at, simple to understand. It also happens to be popular for people who are learning to program. Python is a language. A framework that might go with it is Django. So you might hear of that. So if you hear about Django, what you're actually talking about is a Python developer, usually. It's on the flexible side of languages. And this is sort of a coincidence. This is sort of an accident of history, but Python is also real popular with data scientists. And I'm sure your clients are asking you about data scientists. We'll talk about that a little later. So yeah, keep that in the back of your mind as well, that data scientists also really like Python for the most part. Okay, so let's talk about mobile a little bit here. I put two languages on one slide: Objective-C and Swift. So these are the languages that you use if you're going to program apps for the iPhone or the iPad, or possibly your Mac computer as well, your MacBook. Both of these languages come from Apple. And the thing to understand, why are there two of them? Well, the short version is that Objective-C is old and Swift is new. So Objective-C has been around for a long time, more than 20 years. Speaking personally, I find it hard to look at. It's ugly. It's hard to use. People like it though. I mean, that's just my opinion. But it is an old language. It is pretty old school. It's hard to deal with sometimes. And Apple recognized this. So a few years ago, probably 3-4 years ago, they created Swift, which is a new language for creating iPhone apps. It's nicer, it's easier to understand, it's more advanced, it has some sort of more advanced, more modern features. An iOS developer, an iPhone developer, will use both, typically. It's typically not one or the other, you kind of have to use both. Older apps are written in Objective-C, so there's lots of existing apps that are built on Objective-C, so it's not going anywhere. But anything new that a developer is building, any sort of new app, in all likelihood they'll use Swift. We'll talk about a few more here, what I like to call hipster languages. New languages are invented all the time, again, because we can, because we can do it. They appeal to curious programmers or more advanced programmers. I know a lot of people like this. I'm like this once in a while. Here are some names, some of which are, some of which you've probably heard of and some of which you haven't. Haskell is a very academic language, for example. Rust is pretty new. Go is very popular. That's a language coming out of Google. And there's some interesting ones here, like all of these names. Like I mentioned, Swift. Swift is still pretty cutting edge, relatively speaking. And there are programmers that just like this stuff. They like new languages. They're curious. They have the sort of mind that can sort of understand new languages. So you might come across these, and it is sort of a style of developer or a kind of developer that is, that is into these things. Okay, frameworks. So frameworks are, we talked about this a minute ago. So languages, okay, we understand what languages are, but we keep talking about frameworks. What the heck is that? And I'm with you. It's kind of a vague term. It's kind of hard to understand. What it is a set of templates. So you don't have to use a framework. Frameworks are helpful to us as developers in the same way that templates are, like a spreadsheet template or a Word template. It's a set of sort of pre-built tools, some sort of pre-built components for us. It's kind of like having batteries included. So when you write something like a website or a mobile app, you find yourself repeating yourself again and again. There are certain tasks that you just do over and over again, and you don't want to have to do it again. That's what frameworks are for. They take the sort of boring stuff and package it up and give it to you, and it makes things easier. It increases our productivity, and we sort of avoid reinventing the wheel. Again, it's optional. It's not necessary to program with a framework, but it is usually pretty desirable to do so. Frameworks are specific to a language. For example, Rails is only for Ruby. There's no such thing as Rails for Python. It would have a different name if it did. So Rails is definitely Ruby. Now, Ruby doesn't definitely need Rails, but Rails is always Ruby, if that makes sense. Okay, I'm going to zip through some sort of example web stacks here. I'll go kind of quickly through these. When I mentioned to you that, web stacks or stacks in general are pretty mix and match at this point. They are very mix and match, but generally you will find certain ones that tend to go together. They don't have to go together. You can use any language with any database if you want to. But generally speaking, these things too sort of trend together. So I'm just going to sort of run through a handful here. The LAMP stack, that's an acronym. You'll typically see these sorts of environments here, these sorts of technologies. Java stack might look like this. You might run it on the Solaris operating system, which is a kind of Unix. You use Java, you might use Play or Spring, and you might use an Oracle database behind it. Again, you don't have to, but for historical reasons, you might see these things sort of go together. Let's see, what else? A Python stack might look like this. You might use Postgres as a database, probably run it on Linux. You might use something like Django or Flask with the Python programming language. So these are sort of common combinations here. Ruby, kind of similar. Ruby and Python actually are, they're pretty close cousins in my mind. So you'll see similar sort of stacks between Ruby and Python. So you see Rails as a framework here, Ruby is the language. .NET. So I mentioned to you earlier, .NET is really more of a branding term than anything. It really just means the Microsoft programming platform. That's really all it means. It does have technical meaning, but we're not going to worry about it too much. But you're talking about C# usually. You'll probably use Microsoft SQL Server as the database. You might run it on the Windows operating system on the server, for example. And there's a good chance you're using ASP.NET on top. And just to reiterate, the reason I mention these things sort of going together is that you can sort of infer things from your client. So if your client says something like, oh, I need an ASP.NET developer, in your mind, you should think to yourself, okay, even though they didn't say so, we're probably talking about a C# person. And there's a pretty good chance they're using SQL Server back there as well. This is a slightly newer stack called the Mean stack. It's MongoDB. Express is a framework. This runs JavaScript on the server. So you might run something like Node and Express on the server. You might use Angular on the front end. It's all JavaScript, sort of front to back. And you might use something like MongoDB on the back end. So, as of a couple of years ago, sort of a new hipster startup their stack might look something like this. Mongo, like I said, is sort of cutting edge as well. Great. Okay, everything I just showed you there are mobile stacks. And I mentioned to you that, web stacks, everything I showed you was a web stack. Web stacks can be very mix and match. You can combine things, and mostly it works. You can kind of use any database with any sort of language if you want to. Certain things trend together, but you can mix and match. That is not true on mobile, for the most part. Mobile is much more locked down than the web is. So mobile tends to be quite a bit more proprietary. There's only two big games in town, Android and iPhone. If you squint, you can see Windows Phone, but it's really not a thing anymore. Unfortunately, Windows is actually a very nice phone, but they lost in the marketplace. So we're talking about Android and iPhone. In terms of unit sales, in terms of just the number of phones in the world, approximately 80% are Android and approximately 20% are iPhone. Now, that said, Apple and the iPhone makes way more profits than Android does. But in terms of physical units, in terms of the number of phones in the world, Android is actually much bigger. And as I said, the technology is much more locked down. We as developers have a lot fewer choices when we are dealing with mobile apps. So on the Android side, pretty much all of these things are what you're going to use. You're going to use Android Studio in all likelihood as the sort of tooling. Java is the programming language. There's not really a database. I mean, there is, but we don't talk about databases too much on mobile. Android operating system. And the hardware, this is interesting, the hardware is made by a lot of people. Android is an open source operating system, and what that means is lots of companies can take their own copy of Android and make their own phones. And that's great for sort of competition. So you can get an Android phone from Samsung, you can get one from LG, you can get one directly from Google, actually. That's what I have here. Yeah, it's sort of a more competitive environment, sort of an open source environment. But even so, it's still pretty locked down. I can't use any language. I pretty much have to use Java if I'm programming on Android. That's not technically true, but it's a practical matter. It's true. Over on iOS, so iOS is the operating system that runs on iPhones and iPads. In all likelihood, they'll be using Objective-C and Swift. In fact, they kind of have to. Again, it's very locked down. It's running iOS as the operating system. And the hardware is always made by Apple. So this stuff is definitely not open source. Some of it actually is, technically, but most of it is not open source. It's really locked down. You have to use Apple's tools. Every one of the tools I've listed here is owned by Apple, run by Apple. They control all of it. It's all very proprietary. But it works. It works. There's lots of iPhone developers in the world. One thing to understand about mobile developers, and we'll touch on this in a minute, mobile developers, generally speaking, are one or the other. Either they program Android or they program iOS. They rarely program both, or at least they don't do it very well. And that's not meant to be an insult. It's just that there are specialties here. So the reason I mention this is your clients may be asking for a mobile developer that does Android and does iOS, and that's unrealistic. That is unlikely. You'll probably want to tell your customer that they need one for iPhone and they need one for Android. They probably need two programmers. Okay, I'm going to make a restaurant analogy. I'm going to stretch it a little bit here. People want to talk about the stack a little bit. What is the analogy of a stack? So here's what a website is sort of made of, these sort of 5 parts here typically. And so the metaphor is this. The HTML, which is how your web page is put together, that is the structure of your web page. So it's sort of like the floor plan. It's sort of like the tables and the doors of your web page. The CSS, that's the decor. That's the aesthetics. That's your color choices, and that's your tablecloths, and that's your paint colors and nice fonts and all that sort of thing. JavaScript is the waitstaff. JavaScript is the thing that actually does stuff. It takes orders. When you say go do something, JavaScript is the thing that goes and does it. What is the back end here? Well, the back end in this metaphor is the kitchen. You as a diner usually don't see the kitchen, usually. But it's back there and it's working really hard, and it's working hard to serve things up to you on the front end. I guess restaurant people call this front of house and back of house, maybe. So, front end is front of house and back end is back of house. So there's all kinds of stuff happening in the kitchen. Similarly, on a website, there's all kinds of stuff happening on the back end. You just don't see it. It serves everything up to you on the front end. And if you even go further back, there's food in the pantry, there's food in the walk-in freezer as well. That's the database. That stuff needs to be stored and it needs to be kept good. If you lose your pantry, if you lose your walk-in freezer, then it's pretty hard to do all the other stuff. And that's sort of true here. Okay, some specializations. These are skill sets. These should start looking familiar to you now that we've sort of blazed through a bunch of these. On the front end, okay, so there are specialists. Front-end specialist is a person who does HTML, CSS, and JavaScript. I mentioned to you on the front end that there are a million JavaScript frameworks. So a front-end person might do React. They might do Angular. They probably do jQuery. And there's a bunch of other examples there. That's what a front-end person focuses on is HTML, CSS, and JavaScript. A back-end person prefers stuff that's in the server side, back in the kitchen, basically. They do Ruby or Python or Go or C# or something like that. They worry about databases, they worry about networks, they work on the back end. We mentioned this earlier, a full stack person does both. They can do the front end, they can do the back end. And from a skills perspective, the reason we want this is that they can build the whole app themselves. So you can sort of hand over a task, hand over a specification, and they can build the whole thing. Mobile, we talked about mobile already. iOS and Android are the two big games in town. For a person, for a mobile developer, they typically don't do both. They might. I know some people that do both, but usually that's not the case. Usually it's one or the other. And you should let your client know that typically if they want, to do both iPhone and Android, they probably need two mobile developers for that. It's not strictly true, but it's probably true. All right, a few more specialties here. Systems administrator, there's a few different terms we use for this. A systems administrator, also called an SRE, which means a site reliability engineer. They're dedicated to the low levels of the stack. So the hardware, the operating systems, the servers. They keep all that stuff running. There's a particular word that comes up lately called DevOps. It's very close to a sysadmin, but this is sort of a special kind of person. They are a systems administrator, but they're also a good programmer. So they can act like a developer or they can act like a sysadmin, and really they can sort of act at the intersection between those two things. These are really valuable people. They're very desirable people. We've got a few of them here at Stack that fit that description. I'm sure your client wants them. They are expensive and they're hard to find, but they're really valuable if you can get one. The metaphor I would use here is like, imagine you are making a movie and you want somebody who is an excellent actor and also an excellent singer. That's possible. We know people like that, but we also know that it's rare. And that's sort of what a DevOps person is. We talked briefly about a database administrator already. We say DBA for short. This is a systems administrator. It is a specialty within systems administration to do database administration. So it is a sysadmin position, but focused on just one particular part of the stack, which in this case is the database. By the way, we have a website, sort of a sister site to Stack Overflow, which is dedicated to systems administrators. You can target jobs to that site as well. The thing to keep in mind is that Stack Overflow does way more traffic than every other site on our network, including Server Fault. Server Fault is a very popular site, but Stack Overflow is 10 times as big. So you can target ads to also appear on Server Fault, job ads I mean. And it will be helpful, but it won't give you a huge bump. It'll give you like 5% bump, maybe something like that. A couple of other specialties, desktop applications. So like Microsoft Office, that's a desktop application. It's a thing that sits in your dock on your Mac or sits in the taskbar on Windows. If you click one of those things, you're clicking on a desktop application. Prior to the web and prior to mobile, this was sort of the only kind of application. These days, since the web and mobile have taken over, desktop is not nearly as popular. But there's lots of them, lots of desktop apps out there, so people might ask for desktop developers, and that means an application that runs on your laptop typically. Embedded developers are interesting. They're also in demand. So there are lots of things in the world that don't look like computers, but they are. Cars have lots of software in them. TVs have lots of software in them. Medical devices. And so there are programmers who specialize in this sort of software. It's embedded software. It's a bit of a niche, but it's in demand. It's highly skilled. So you may have clients asking for this, especially if they're sort of a hardware company. They may be asking for embedded developers. Data science. This is a big one. I'm sure your clients are asking about data science. So a data scientist is a statistician and a programmer, basically. They take data and they try to make predictions and they try to help us make better decisions based on data. They are analysts and statisticians. Many of them have PhDs. This is a a highly I don't know if technical is the word, technical, academic, mathematical field. These people are very in demand because the truth is every business needs a data scientist. If you don't have a data scientist, you're not analyzing your data. You're probably not making very good decisions about your business. This happens to be a particular, pet thing of mine. But every company, every department in a company, actually needs a data scientist, and they don't know it yet. So they're very in demand. The technologies they use are typically R and Python, and there's lots of sort of specific technologies within those broader technologies that they use. You'll hear terms like machine learning, artificial intelligence. From a hiring perspective, these are all basically the same thing: data science, machine learning, AI. Don't worry about splitting hairs between those definitions. They're effectively the same when it comes to recruiting. Okay, that was a lot. This is the last slide. So I'm just going to briefly talk to you about open source software. From a hiring perspective, a recruiting perspective, open source is not critically important, but it is interesting. The reason it's interesting, it might be interesting to your clients, to recruiters, is that many programmers use open source as a way to show off a portfolio. So open source software just basically means I show you the code that I wrote. I put it in a public place. You can share it. You can go use it if you want to. This used to be a radical idea. 20 years ago, this didn't happen very much. 20 years ago, Oracle was very proprietary, and Microsoft, etc., etc. But these days, the world is very open source. Companies like it. They make a lot of money on open source, which is a whole topic unto itself. But Microsoft and everybody else has gotten very open source. Google is good about open source. Facebook is good about open source. Very popular software that's out there is open source. Linux is open source, Ruby, MySQL, all sorts of stuff. Angular, React, all that stuff, that's all open source. So again, don't worry too much about what it means. Just know that the world has gotten a bit more open when it comes to programming, and that programmers sort of like sharing things and they like showing things. And that one purpose that it serves, again, as a developer, it serves as a portfolio. So it's a way of me sort of showing my credentials to potential employers about the sort of work I do. The big name here is GitHub. Typically, GitHub is the place where a lot of people put their open source work. All right, and that's it. Thanks very much. Again, this is meant to be a train the trainers sort of video. So you should do this in person. Get a developer, sit down, talk through these slides. Here's a couple of more places where you can reach developers. You should talk to them because they can just tell you what the market is like, basically. We have a Slack channel called Tech Talk. We have a mailing list called Ask at Stack Overflow. You can just email that list. If you're in an office, you really should try to get to know a developer if you see us walking around. Again, because we are the market, for hiring, and we'd be happy to tell you, what it's like and how it goes, and we'd be happy to explain to you, how these skill sets work. So, thanks very much.